Join the conversation.
You're with Cape Talk.
So that question's been bugging you for all of your life. This is the time to exorcise it from your mind. Of course, it is Dr. Chris Smith. He is a fountain of knowledge and information. He's the naked scientist. He joins us on the line. Good morning to you, Dr. Smith. It's good to have you back.
Yeah, likewise. It's good to be back. You know, I had one of those amazing scientific experiences yesterday. Well, I had two, actually, but I'll tell you about one of them. I met a guy who is making stem cells from blood donations grow in the laboratory to grow new human blood. And it's not just a lab thing. They've actually got this to the stage now where they are about to start a trial where they will put these blood cells into real people, volunteers, to check that they work okay and they survive in the bloodstream for a long period of time. And they reckon they'll last in circulation much longer than blood that you put into a person from a blood donation because the cells are all young. Whereas when we donate blood, which is an important thing to do, you give blood which is both old and young because you're making new blood all the time. So they reckon they'll be able to reduce the transfusion frequency for people with certain rare diseases that are going to need blood transfusions much more frequently. Isn't it amazing what science can do?
If you are amazed, Dr. Chris, then that must be a significant development.
Well, if people want to hear it, I'm going to publish this as a podcast this morning on the Naked Scientist website. So if you check into nakedscientist.com later today, you will see this story go up and you can hear from Cedric Gavert at the University of Cambridge. He's one of the people in this project talking about how he's done this. I think it's brilliant.
Okay, so if dialysis is part of your life's routine, you want to go to that particular website and familiarize yourself with where developments are at. I think we're going to jump straight into the question and the naked scientist. And of course, your questions. This is the first one. It's FIFO. That's the rule that we apply first in, first out. The first question in today. Hello, Dr. Chris. In light of the global warming seminars happening, I Googled the amount of fuel space rockets burned to enter space. In year 2021, a total of 1,800 rockets were launched. At liftoff, the two solid rocket boosters consume 11,000 pounds of fuel per second. That's 2 million times the rate at which fuel is burned by the average family car. Should we not be reducing space programs? Lawrence with that question.
Hello, Lawrence. Well, obviously, every little helps, and we should be careful and do good stewardship with our energy and with our resources, whatever they are. But one has to keep a sense of proportion. Every year, we blow off into the atmosphere about 30 to 40 billion tonnes of carbon dioxide. So a couple of rockets is a tiny fraction of that. So in the grand scheme of things, yes, the rate at which those things burn fuel, the rate at which they convert energy is huge, but there are very few of them. So therefore, their individual carbon footprint is very, very small. It's the small things that there are a lot of that really make a difference. It's the fact that each one of us has our own carbon footprint for heating our homes, driving our cars, going on holiday. If you take international flights, they're a big contributor. So when you add all those things up, and then the general mundane generation of electricity from burning oil, burning gas, burning coal, a coal-fired power station in an afternoon will go through 50,000 tonnes worth of coal. And that's not an understatement. It will. And that's just one power station for just one part of a country. So when you take those things into consideration and you say, well, we're pushing forward the frontiers of science, we need to do some of these things. There is a necessary spend. You've got to spend money or energy, whatever it is, to do some of these things. You have to decide what to spend your limited resources on. It doesn't mean you're profligate with them. It doesn't mean you waste them, unless you're certain politicians we're all familiar with. It doesn't mean you steal them. But what it does mean is that you are careful and you spend wisely. And the space program, many would argue, does have tangible return fringe benefits for life on Earth. So it's worth getting things up there so we all benefit.
Okay, let's go to Zuki. Zuki sent us a voice note.
Good morning, Clarence and Dr. Chris. I have the assumption that most animals eat the foods that they eat because they need them for survival. And there's some kind of instinct that makes them seek them out. So I was wondering if humans have the same instinct. I know we grow up getting used to flavors and salts and sugars and stuff, but if those things did not exist, would there be foods that we would naturally gravitate to that are necessary for our survival?
Hi, Zuki. Well, one example of this, which was put to me a few years ago, was someone actually from South Africa phoned me up and said, why is it that when I was pregnant, I developed a taste for all kinds of weird stuff that I would never dream of eating in a million years when I wasn't pregnant? And I said, well, like what? And this woman said, I wanted to eat coal. And I put this to a scientist who studies the olfactory or smell system, because most of what we call taste is actually smell. And I said, why did this lady say she developed a strange taste for coal when she was pregnant? And he made the point that when you're pregnant, big metabolic load on the body, you're also increasing your requirement for rarer or trace things that your body needs only in tiny amounts. So you do change your taste repertoire sometimes when you're pregnant to make yourself more gregarious in terms of what you'll eat, in order to make sure you do have enough of all the right things. So there's an element, therefore, of behavioural control. The brain is tasting and sensing what's in the bloodstream. It's looking at the calories that are coming in, and it's also looking at the micronutrients. And there's evidence that we are continuously sensing our micronutrient supply, and we change our diet, we change our appetite accordingly to try to balance up what we eat. It's therefore likely that other animals will also have natural instinctive tastes for certain things that can provide them with what they need. Really good example of this, think about our worst enemy, the most dangerous creature on Earth, the mosquito. Mosquitoes cause more deaths in humans than anything else because they spread malaria, but it's only the female mosquitoes that do that, and they only do it at certain times of the year because they drink blood. The rest of the year, just like their male counterparts, they drink sugar from fruits. But when they're laying eggs, when they are doing something that's metabolically very demanding, and they need a lot more protein in their diet to make eggs for making baby mosquitoes, then they change their behaviour, they change their diet, and they start biting us to drink our blood. So the answer is yes, there are instinctive mechanisms that make animals want to eat certain things anyway, and then there are behavioural mechanisms that can supplement those things with other sorts of dietary sources to make sure we don't run short of certain things.
Let's go to the phones. Ronnie in Mowbray on the line. Ronnie, go ahead for Dr. Chris.
Hi. My question is, what evolutionary purpose did it serve for humans to learn to do math? And are we the only animals that can do math?
Well, what a great question, Ronnie. The answer is no, we are definitely not the only creatures that do maths. It depends really what you define as maths, but it ranges from animals as simple as bees right through to us, animals that have the ability to count. If you hold up some fingers to somebody and say, how many fingers am I holding up? A person in one glance can tell you, about 5 or 3. If you hold up 15 fingers, they won't be able to do it. This is called subitizing, and many animals have the ability to make good approximations of small numbers of objects. And the reason we think that animals, including us, can do this is because there are many other social species on Earth like us, where numbers count. If you're a pack of wolves or a pack of dogs, and you see another rival pack coming your way, if you can quickly tot up roughly how many of them there are, you can make a judgment about how likely you are to come off on top as top dog if you and them have a tete-a-tete. And we're the same. And it gives you an advantage if you can work out proportionally how much of something is there. Insects also do this. There are beautiful studies done on bees where people have proved that bees can count. There were some experiments published a few years ago where researchers taught bees to fly through a primitive maze system, and they had to fly over a certain number of obstacles before they got fed. And the bees quickly learned and could count. I go 1, 2, 3, and there's the food. And if you think about it, that's fundamental for them being able to navigate and find food sources, because they teach each other back in their nest. This is the direction to fly and this is how far to fly, so they can count. And part of that is food and so on. Ants also count, and there was another amazing study in the journal Science about 10 years ago where researchers proved that ants find their way to and from their nest by counting their steps, and they proved that that's what they were doing. And it sounds pretty awkward, this, but they got some ants and they glued stilts onto their legs to make their legs much longer than they should do. Now, if the hypothesis that ants are counting steps rather than following other cues to get home is right, then if you make an ant's legs longer, it walks further with each step, and therefore it should overshoot the nest, and that's exactly what happened. If you then do the converse and you chop the bottom off their legs and make them too short, they should if they're taking the same number of steps each time, arrive too short of their nest. And that's exactly what happens. So even ants can count, and they can count how many steps they're taking to find their way around. So an ability to do maths, even primitive maths, seems to be fundamentally hardwired into even the most basic of nervous systems.
And that was a fascinating response. Now let's go to a voice note.
Good morning, Clarence, Dr. Chris. So I have a question about randomness. And so I have 2 earpods. One left, one right. The receptacle wherein these iPods go is a left and a right, which one would assume that there's a 50% chance that I would put the right phone into the right holder. Yet 70% of the time I get it wrong. I have 2 keys that look pretty much the same, and I have 1 lock. So there's a 50% chance theoretically that I should pick the right key to open that lock. Yet 80% of the time I will take the wrong key. Why is that?
This could be gambler's fallacy, in the sense that when you say to yourself, I have been on a losing streak, so the next time I'm going to win, it could be partly that. It's also that there could be an attachment of significance to coincidence here. These are very precise numbers, 80%, 70%, that are being cited at us. But have you really done the experiment? Do you know that's the case? Because humans are heavily biased. We tend to notice the things that meet our expectations or work the way we expect them to, or contrarily, don't meet our expectations. We tend to really pay attention when things don't quite match up. And as a result, what could be happening here is that the 50% of the time that the earpod, by just sheer chance, goes into the right hole, we go, oh, I won't notice that one. But the time it goes wrong, you think, damn, got it in the wrong hole again. And as a result of that, you apply more significance to the time it doesn't happen, to the times that it does. And it biases your thinking that is the rule rather than the exception, or just 50-50. So I would challenge you that those numbers are accurate. And I would say, go and do the experiment in a blind way. Get somebody else to do this, and you measure how many times they get the wrong key for the wrong hole or the wrong earpod for the wrong receptacle. I reckon you'll find in enough time it'll come out 50-50, because what you're basically saying is I take a coin, and it's a fair coin, and I flip it 1,000,000 times, and 700,000 times it comes up heads. Now, there's a chance that could happen by chance, but it's a slim chance. And if you do something enough times, eventually the noise will iron itself out, and you'll arrive at what is the real rough average, and it should be about 50%.
Let's go to Neil in Woodstock. Your question for the Naked Scientist, Neil.
Yeah, good morning. With our eyes firmly on the environment, we are heading for disaster, so we're told. But at the same time, we're producing and putting more 4x4s on the road. I don't understand the equation. Or does it make no difference that people are driving 4x4s over and above standard sedans? I don't quite know.
No, it's a difficult one. The bottom line is that everyone wants to have their cake and eat it. We want to have this nice, comfortable life that we all aspire to or have already or want to make even nicer for ourselves. We want to have all of these trappings and trimmings of luxury, but we don't want to pay for them. It's a bit like having a credit card that someone else pays for. That's what's happening at the moment, where we're going on a spending spree and we're churning out all this CO2, and we're then expecting someone else to pick up the tab, and that someone else is the environment at the end of the day. And so we do have some tough choices to make. We are changing the climate of the planet. To what extent remains to be seen. We have ejected something like about 1 trillion tons of carbon dioxide is in the atmosphere now that wasn't there about 200 years ago. It's at the present rate going up and up and up. And unless we do change this, there almost certainly will be consequences. We're pretty agreed on that. You can't change the composition of a gas in the atmosphere on the scale of an entire planet by about 50%, which is what we've done to the CO2 levels in the last couple of centuries, and not have consequences. And it's not just a global warming phenomenon. That CO2 is also going into the ocean. The reason temperatures haven't gone up faster than they already are is because a lot of it's being drawn down into the sea. And when it gets into the sea, what it's doing is turning the sea into a more acidic environment. and a more acid ocean also has knock-on effects for the animals that live there. It affects the rate at which animals can build shells and skeletons, for example. So there are other consequences as well. And part and parcel of that is, we've got to do, I was saying earlier, doing good stewardship with our resources. There are some things which are necessary. There are some things which we think are a good use of resources. If you are an outback explorer or you're taking people to show them nature out in the bush, then you need a 4x4 to do that. And if that means that those people are much more aware of the wonderful things that are out there in nature and have a better motivation to protect them, then that's money well spent, it's carbon well spent. But if on the other hand it's just to cruise around town and impress your mates, that's less good in judgment terms. So we've really all got to make some sacrifices, and it means doing good stewardship with the resources we have.
I think we're going to go to another voice note. Let's take a listen to this one.
If we think that molten lava is coming from the core of the earth to the surface, if that continues continuously, theoretically speaking, the earth would collapse because the core of the earth is being eroded away. Is it so? Yes or no? Is it just in the realms of theory from STEMRay?
Okay, mate. Well, there's a couple of things to unpack here. First is that molten magma, which is the runny rock from inside the earth, is a tiny fraction of what's in there. The distance between the surface of the earth, where my feet are, our feet are, and the core, the centre of the earth, is about 6,000 kilometres. So one volcano is a tiny, tiny fraction of what's down there. That's the first point. So even if it did all splurge out onto the surface, it is not going to cause a major problem for the interior of the Earth. The second point is that the Earth is continuously recycling and refashioning itself. In some parts of the Earth's surface, the crust, are being consumed into the innards of the Earth because the heat, the temperature, friction, pressure causes the rock to melt and contribute to the magma reserves inside the Earth. In other places, high pressure and redistribution of that magma is spewing the stuff out on the surface in volcanic eruptions. So the whole thing really is in balance, and what keeps it going is that the interior of the Earth is very hot. It's about 5,700 Kelvin down there, and that is well and truly enough to melt rock and keep the rock runny. And what keeps the heat in there is that to a certain extent there's friction. There are things sinking and rubbing against each other as they sink down inside the Earth, and the Earth was also hot to start with, so it started with a lot of heat, but there's a lot of radioactive material, including things like potassium-40 inside the Earth, and as they radioactively decay, they contribute heat. So what's really driving what's going on inside the Earth is a thermal effect, because the planet's hot, and when things are hot they expand and move around, and therefore this will continue until the planet cools down, and then the process eventually will slow and stop. But for now, we are not in danger of opening up a void inside the Earth, because what goes up and comes out is going in somewhere else.
Okay, we're fast running out of time. 2 WhatsApp questions in. Do animals die from malaria is one. And then the other one, my normally docile bees kept in a hive for years suddenly swarmed out and started attacking my neighbor's 2 huge dogs. What could have triggered this reaction?
Malaria answer first. The answer is yes. Other animals apart from humans do succumb to malaria. There are various other strains or variants of malaria, one called malaria Plasmodium knowlesi, for example. These affect monkeys. So yes, our close animal cousins also get malaria. Mice can catch malaria as well, so it's not unique just to humans. The bees swarming question, what keeps bees in check is the queen. And as the queen goes about her business, beesiness, she secretes various chemicals, including pheromones, that control the behaviour and damp down the aggressiveness of her brood of bees, those workers that look after her. But as the queen gets older, she loses her ability to produce enough or as much of these chemicals, and that means the bees are kept on a less short leash, and they're more likely to run amok and start to misbehave. And so it sounds to me like it could be that hive has either got big and the queen has got old, or the queen has died, and as a result of that control that was being exerted is lost, and off the bees go.
Let's go to Lionel in Brackenfell. Your question for the Naked Scientist, Lionel.
Dr. Smith, my son can control the hot water cylinder with his cell phone. How the devil does he do that?
Well, Lionel, the answer is, and this is the way we're going actually, the e-home, the wired home, the way it works is that you can install various devices which are online, so they are on the internet, and you can dial into them using a device that knows effectively the postcode, the address of the device in your house, and will do a handshake electronically over the internet and say, right, I want to send a signal that tells the device in my home to turn on and off various devices. This is actually quite common. People are doing this for not just the water heater, but also even turning their oven on. And people have even got plant watering devices that are on the internet. So when they go on holiday, they can dial in and they can water their plants at home. And at the same time, also keep an eye on their home. You can buy security devices that do exactly the same thing. They'll activate a camera and beam you a picture of your living room. So when you're sunning yourself on the beach somewhere, you can still be close to home, as it were.
Thank you, Lionel. Let's get Oliver with a really pressing concern. Oliver, go ahead. Durbanville.
Hi, good morning. I'd like to know, why do your eyes water when you trim your nose hairs?
Oh, hi, Oliver. Yeah, happens to me as well, and it's excruciating, isn't it? There's nothing that compares with the sensation of pulling a hair from your nostril, especially the hairs that grow from the septum, the bit in the middle. That's the most excruciating. The reason that you cause that tearing response is that there's a nerve reflex that when something irritates your nose, it also makes your eyes water. And I think the rationale behind this is that when you blow your nose, then you tend to reflux things up your tear ducts a bit. And so by making your eyes water, you also flush that out. And at the same time, when you're pulling the hair out, you screw your eyes up. And that does two things. One, it squeezes on the glands that make tears and makes more come out. And two, it squeezes on the duct that drains the tears down into your nose and stops the tears temporarily draining down. So as a result of that, you then notice you've got lots of tears around your eyes because you carried on producing them, and in fact you produced more of them, but you couldn't get rid of them. So you have this double whammy effect. So I think it's partly that the stimulation to the nose increasing the tear production, which makes you notice it, and two, screwing up your eyes makes more tears and stops you flushing them away, so you notice it more for that reason as well.
A last question, and we got about a minute in which to answer it. Naked Scientist, why are there more dinosaur fossils than Homo sapien fossil finds? I thought our graveyards were full.
Well, we're talking about here the evolution of Homo, our lineage, and this goes back 2 million years or so. And the reason that they are relatively sparse is that there were relatively few of us back in those days. And to find a fossil, you're talking about something that's got to have been there for a couple of million years, long old time for something that was relatively rare in the first place. The conditions have got to be perfect to make a fossil. Dinosaurs were huge, there were lots of them, and they were around for a really long time, 100 million years plus. So we're more likely to stumble into them because they're more likely to have left something behind, because there were fewer of our ancestors, then their finds are much rarer proportionally.
And we're going to have to wrap it there. That's our weekly engagement with the Naked Scientist, Dr. Chris Smith